Okay, this is Site C. On Site C, we are looking at different rock samples. So we have 4 rock samples. Okay, so let's look at sample number 1. Okay, this is a coarse-grained igneous rock. See how you can see all of the different crystals within the rock? You can see the shape of the crystal and everything. Okay, so it's coarse-grained and has large crystals. So let's go to our chart. So the grain size is coarse or large. All right, and let's go back and look at our rock again. Okay, actually I'm going to go back and we're going to do the grain size for all of them first. All right, here is the next one. Okay, this igneous rock has a glassy texture. Note the shiny curved surfaces and sharp edges. Even in a magnified view, this rock shows no crystals. See how it is very, very smooth. Okay, so let's go to our paper. And for sample number 2, the grain size is small or fine. Now let's look at sample 3. This one says it has a porphyritic texture. We'll find out what that means in just a minute. But since you can see the size of the individual grains, it is also a coarse-grained rock. So number 3, large, coarse. And then the last one is number 4. Number 4, you can see little holes in it, but you can't see actual grains. It's all pretty much the same color. So this one is fine-grained. Now we're going to look at the color. So this one has some pink and orange and some black and white. So I will add those colors in. Number 2 is all black. Okay, so if we look at number 2, this is all black. Number 3, okay, it has some dark brown and tan. Other features of the first rock. Okay, has large interlocking crystals. The second rock is smooth and glassy, which is already filled in for you. This third rock has large light-colored crystals surrounded by darker fine-grained crystals, so it actually has a mixed texture, which is what porphyritic means. And number 4. I would say that you can see the vesicles, which are the little air bubbles. This is a fine-grained igneous rock. The small crystals are only visible with a magnifying lens or microscope. The holes in the rock, called vesicles, show where gas bubbles were trapped as the melted rock solidified. So we will add vesicles, bubbles. Okay, now we're going to be clicking on page 5 of the simulation and looking at the pictures for information. So down here, page 5, let's allow Adobe Flash. Okay, so this is a volcano. Let's look at the pyroclastic flow. Okay, so it said pyroclastic flow. Quick cooling results in small crystals surrounding the large crystals. Now let's go see what it says about the lava flow. So here is a lava flow. Quick cooling results in many small crystals. And then the gas bubbles form vesicles. Quick cooling results in many small crystals. Gas bubbling out of the lava form vesicles in the rock. And now let's see what magma will cause. So here's our magma chamber. Slow cooling results in large interlocking crystals, like we saw in this piece of granite. So here we can write slow cooling results in large interlocking crystals. Okay, and we're going to look at page 6 and fill in the information about each igneous rock sample. So what we're looking at is the cooling rate. Did it cool fast or slow? And the environment. Where did it cool? So let's go to page 6.